All right, here we go. 9-4. We're talking about vectors. Page 620 if you want to follow along. And I've got some formulas for you. And what we'll do is we'll just start with the standard form of a vector. That is the standard form of a two-dimensional vector. And that does say AI plus BJ. Vector V, AI plus BJ, where the AI is the X component of the vector, and this is the Y component of the vector. So far, so good? Okay, next. And for lack of a better term, I'm going to call this the two-point formula. And that formula is used to get the standard form of a vector if you know the starting point and the end point of the vector. Are y'all keeping up? Am I going too fast? Okay, let me go back and give you a couple other things here about vectors. Do y'all know really what a vector is? Okay, so a vector is something that has both magnitude and direction. Every vector has a magnitude and a direction. And this is most commonly used. You'll hear this a lot if you watch movies that have aircraft involved. And they'll say, you're on a vector, blah, 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 right? You're on a vector, and that means that you have a certain speed and a direction. The magnitude sometimes is referred to as the speed and the direction, or magnitude could be the length and the direction. Okay? Yes, sir.
Is it similar to like when space shuttles like try to re-enter the atmosphere?
Exactly. If they're not on the right vector, if they're not at the right angle and the right speed, yeah, you'll bounce off or you'll enter too steep and burn up. Yeah, so that's important. Yeah, and die, yeah. Important to mention death there. Everybody that leaves here tonight is going to be on a vector. Whether y'all know it, when you get in your car, you're going to have a direction you're going, right? And then you'll either have a distance to your house or a speed. Remember, the magnitude is either the distance or the speed, whichever one you're talking about. So every one of y'all, when you get in your car tonight, you just think, oh, I'm on a vector. The vector home. All right, next formula. And this is the formula for the magnitude. That is the magnitude of the vector. So in this case, we're referring to length. Magnitude is the length. Questions so far? Okay, next. We have the formula for a unit vector. And a unit vector is a vector that has the same direction as the original, but has a length of 1. Every unit vector is going to have a length or a magnitude of 1. All right, we have another formula. Let's see here. Cosine theta. I plus sine theta j. Bam. And we're going to call this one the M and D formula. That's an abbreviation. The M and D formula. Anybody want to guess what M and D stand for? Yeah, that's the magnitude and direction formula. Because this symbol right here, that is the symbol for magnitude, and theta indicates a direction. Right? Remember we talked about in the unit circle, the plotting the polar points, you have to figure out the direction first. So theta is the direction you're going. And then this, if you plug into this formula, you get standard form. How are we doing so far? Do you think that's enough formulas? Or do you think that I need to give more formulas? Let me see if I can find one more. Yeah, let's do one more. I'm sorry, Amina. I'll scroll up in a second. There you go. That's the direction angle. Or at least that's what the book refers to it as. Find the direction angle. And that is the inverse tangent of B over A. All right, let's go and do some problems. Let's see here. Use the vectors in the figure. Okay. All right, we've got W U and V. All right, so what I've done here is I've sketched to the best of my ability what's in the book for vectors U, V, and W. And do y'all remember that I said every vector has a magnitude and a direction? So if you look at these vectors, each one of these vectors has an arrow on the end of it, and the arrow is to indicate the direction it's going. The length is the magnitude. For these vectors, the length of the vector is the magnitude of the vector. And what we want to find first, problem number 11, says to find V plus W. And the way we're going to find V plus W, we're going to use something called the, is it the tip to tail method? Tail to tip method. Whichever one sounds good to you. Tip to tail method, okay? V plus W. So do y'all see what vector V does? How many units does it go to the right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's vector V. And then we're going to attach the tail of W to V, to the tip of V. So what does W do? It goes up 5 and over 2. All right, here we go. 1, 2, 3, 4, 5. 1, 2. And there's W. Do y'all see what I did there? I think it's called the tip to tail method. But whichever vector is first, you lay that vector out, and then you attach W, the tail of it, to the tip of V. Yes or no? You got it? Now, since we're doing vector addition, this vector is going to represent V plus W. That vector is V plus W. So if we wanted to, we could say that V plus W is going to go over 7 and up 5. V plus W is over 7 and up 5. There's Carlos. Questions about that? All right, number 13. Yeah, I'm sorry, the answer is the drawing. If you're wondering what is the answer really, it's the picture. So this indicates V plus W right there. Number 13 is 3V. Yeah, this one's going to be easy. 3V. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So do y'all see if you multiply a vector by a number? Y'all might want to write this down too. What I'm about to say is important. They call that scalar multiplication. Scalar multiplication. Multiplying a vector by a constant. All it does is it increases the length of the vector. Say it again. Oh, when you multiply a vector by a constant, they call that scalar multiplication. And surely y'all have heard that in a phrase before. Have y'all ever heard somebody say, let's take this and scale it up or scale it down? Scalar means increase or decrease the size. Do you notice that vector v has the same direction as 3v? It just is 3 times as long. So scalar multiplication increases the length, but it doesn't change the direction. Got it? What about vector addition? Yeah, you have a new angle, right? It's going to have its own angle compared to the other two, and it will change the length as well. Wow, and those are some of the more abstract things you do is working with vectors as far as in a picture. And what we're now going to focus on is working on using these formulas, doing more like vector algebra. Okay, so before I move on, any questions? All right, so be it. Number 31. All right, so if you listen to the way the instructions are worded, it says vector v has initial point P and terminal point Q. Find its position vector. That means to express v in the form AI plus bj. So, since they said that P is the initial point, that means that this has to be x1, y1. You don't have a choice. The initial point has to be x1, y1, and that means that the terminal point has to be x2, y2. And can everybody see what formula has to be applied here? And do you see why I called it the 2-point formula? You got to have 2 points to use it. Yeah. So if you're given the initial point and the terminal point, and you're looking for the vector, that's the formula you want to use. All right, here we go. Let's plug and play. That's going to be x2 minus x1 I plus y2 minus y1 j. Whoa, and let's make sure that I didn't screw that up. The formula does have a minus. And did everybody see that x1 also has a minus? Yeah, so 2 negatives make that a plus. And this was y2 minus y1. Okay, I feel good about that. So what is going to be the vector in standard form? 8i minus 3j. So that would be the vector in standard form. No. The I means that that is the x component of the vector, and the j indicates the y component of the vector. Yeah, okay, let me see if I can make that a little more clear. Let's plot these 2 points that were given. -2, 1. And 6, -2. Do y'all see what I did there? All I did is plot the 2 points. But remember it said initial point P and terminal point Q. And so that means that the arrow tip has to go at Q to indicate the direction. And now let's look at it like this. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Now, what did I say? I said that the I part is the x component of the vector. And does everybody see that the distance along the x-axis is 8? That's the x component of the vector. What does the j represent? And do y'all see that it is negative, which indicates down direction? And positive 8 means to the right 8. Everybody see how that exactly what that means in relationship to the picture? X component and y component of the vector. And does anybody have any questions about doing that formula? Do I need to do another example of that, or have you got that? You need to see another example? Okay. Well, let's just do 32. That'll stay close to home. P is -1, 4. And Q is 6 and 2. And do y'all understand that they have to tell you which one is the initial and which one is the terminal? You can't tell unless they identify. No, they have to tell you. Okay, so think about when you get in your car this evening. The initial point of the vector is the parking lot, right? And the terminal point is your house or wherever it is you go. Right? And you're going to have a distance you travel and a direction you go in. Right? But the initial point, you have to know it's in the parking lot, and the terminal point is at home. If you get them backwards, then the direction changes. All right, here we go. So P is the initial. Why? Because they said so. And Q is the terminal. That's where it stops. And then we want to find vector V in terms of I and J. So that's going to be x2. Oh, look out. Minus a negative. Oh, and I made that a J. Oh my gosh, I got carried away. That is an I plus y2 minus. There's my J. Everybody okay with that? Do y'all see it's just plug and play? 6 plus 1, 7i, minus 2j. And so if I was to plot these 2 points on the graph, I can already tell that I'm going to go over 7 to the right and down 2, because that's the x component and the y component of the vector. Now, is that satisfactory? Can I move on to the next type of problem? All right, here we go. Next problem, number 39. And the instructions say, find the magnitude of the vector. So what is the value of A? Good, -2. What is the value of B? And y'all do see where I get that, right? That's from all the way up here at the top. Right? The A is the I and the B is the J. And we're going to plug into the magnitude formula. All right, so that's going to be square root of negative 2 squared plus 3 squared. And I would like that in exact form. I don't want a decimal approximation. I want it exact. And it is going to be positive only because it's a direction and you can't have a negative direction. What am I saying? Because it's a length and you can't have negative length. I'm so sorry. The angle is the direction. This is the magnitude is the length. Go ahead.
Will it ever turn out negative?
You said positive or negative square root, and it's never negative. That's it. But now y'all do remember that magnitude is length. And so if you're going to tell somebody how far, like y'all said, remember I said that everybody's going to be on a vector when you leave here, right? And the magnitude is the length to your house or whatever. Would you want to tell somebody, hey, it's just square root of 13 miles to my house? Would y'all say that to somebody? Oh, it's just square root of 13 miles. Okay, so can I also have this as a decimal approximation? What is square root of 13 approximately? Who has a calculator? Let's go 1.
3.6.
And now do y'all understand the difference between exact and approximate? Approximate is what we use mostly in the real world. It sure does matter. And it's going to be determined by the instructions on the test. It'll either say give the exact value or it'll say round to so many decimal places. Okay? Anybody have any questions about that? Yeah, that sounds better. Hey, it's about 3.6 miles to my house. Do I need to do another example of magnitude? Or have you got that? Anybody need another example of magnitude or you want to move on? Are you good? Okay, we'll do one more. You know why? I want to make one up on my own. Let's say that we've got 5i minus 12j. And I would like to find the magnitude of that vector. All right, so that's going to be square root of 5 squared plus negative 12 squared. And if I'm not mistaken, I think that's square root of 169. And does that square root nicely? So do y'all see, if the number square roots, I do want you to go ahead and square root it. If it doesn't square root nicely, normally we leave it. Now, is that satisfactory and can I move on? Okay, next we're going to go to number 43. V equals 3i minus 5j. And W equals negative 2i plus 3j. Okay, so for problem number 43, they actually go ahead and give us vectors v and w. Those vectors are given to us. What they want us to find is 2v plus 3w. So do y'all understand the two vectors are given, and then they want me to do a calculation with those vectors? Okay, so that means 2 times, what is v? 3i minus 5j plus 3 times, what is w? And do you see, really all I did there was substitution. I substituted for v and w what they're equal to. And then what is the next step in the process? Yeah, I got to distribute. Got to get rid of those parentheses. 6i minus 10j minus 6i plus 9j. And then the next step, just combine like terms. Uh-oh, this problem is about to go blind. Y'all see, it's about to go blind. You know what I'm talking about? Yeah, you're not going to have any eyes. What about negative 10j plus 9j? Wow, and that, yeah, there's not much to that vector. Did y'all know that that vector right there would be a vertical vector? Because the I is the x component, which there is none, right? So there's no left or right movement, there's only up or down movement. Vertical vector. And was that satisfactory, or do you need to do another example similar to that? You want another one? Okay. All right, you asked for it. Let's do number 47. And here's what number 47 says. Now, does everybody know what the two absolute value symbols mean? Magnitude. Okay, this does not mean really positive. The two together mean magnitude. And that means go to the magnitude formula, right? And that's going to be the square root of 3 squared plus negative 5 squared. And do y'all see that I'm getting those numbers from V? And this is the same V that I used over here. It's the same vector. Minus square root of negative 2 squared plus 3 squared. And again, that's just me plugging in the vectors that we had previously into the magnitude formula twice. And then I'm going to need you to work all that stuff out. 25 plus 9, what is that, 34? And that's going to be 9 and 4 is what, 13? And can I subtract those two radicals? Are they like terms? No, I think we're going to stop there. And I don't know if you've heard this before, but in order to add or subtract radicals, you have to have the same index and you have to have the same radicand, which means the stuff underneath has to be the same in order to add or subtract. And it's not, and those are not going to simplify, but I really would like the decimal approximation for that also. Let's say to the nearest tenth. So we can say that that's approximately 2.2 meters, inches, miles, whatever the units are. How was that? Good enough? You want to do another one? Or do you want to move on to the next new thing? Huh? Move on? Okay, we'll move on. Let's see. Oh, okay. Number 52. Let's see. We've got vector v, negative 5I, plus 12j. I've seen that somewhere before. Oh, that was the one I made up earlier, but the signs are different. And here's what the instructions say. It says find the unit vector in the same direction as v. Did you hear them say unit vector? And that means we're going to use the formula for unit vector, which is v over magnitude of v. Now vector v, that's negative 5I plus 12j. All of that is v. And in the denominator, we're going to need the magnitude. So plug it into the magnitude formula in the bottom. And if I'm not mistaken, we've done that calculation already. Right back here where we did the other one. And so we know the magnitude is 13. And so now we know the unit vector is going to be negative 5/13 I plus 12/13 j. And the reason that I split it up into two separate fractions is so that it's in standard form. I can now see what A is and what B is. Any questions? Anybody? Okay, let me ask you a question, something that I've said. I know I said this a second ago, and see if you remember. Every unit vector has a magnitude of what? Oh, you remember. Good. Let's prove it. Let's take our unit vector that we just found and let's apply the magnitude formula. So that'll be the square root of a squared plus b squared. And let's see if that really does work out to be 1. If it doesn't, I need a new job. Because I obviously don't know what I'm talking about. Okay, so I'm thinking the first fraction is going to be 25 over 169. And the other one's going to be 144 over 169. And do those fractions have the same denominator? And that means I can add them. 25 plus 144. But anything over itself? And the square root of 1? Bam, I proved it. The length of every unit vector is 1. Yay. Well, that was fun. Proving that it's 1. Okay, can I move on and do something new? Okay, good. 65. Okay, so for number 65, it says write the vector in the form AI plus BJ, given its magnitude and the angle it makes with the positive x-axis. So can everybody see that they have given me the magnitude and the direction? And what formula should I use? Who said that? M and D. The M and D formula. Do I need to scroll up? Oh, there it is. Look. Magnitude and direction formula. All right, here we go. So that's going to be vector V equals 25 cosine 330 I plus sine 330J. And this would be a great time to go to the unit circle and look up the cosine of 330 and the sine of 330. The unit circle is still in effect. Does anybody know what the x-coordinate at 330 degrees is? And what about the y-coordinate at 330 degrees? And then we're going to go ahead and distribute the 25 so that we can write the vector in standard form. That's going to be 25 square root of 3 all over 2. And that is the x component of the vector minus 25 over 2. And that is the y component of the vector. If you have a nice calculator that'll give you those fractions, you sure can. You sure can. But if you have a TI 83 or an 84, I wouldn't do it. No, because probably on the test it's going to say give the exact value. And I'm going to walk this with the square root of 3 in it. But yeah, you can distribute right here and just put that in your calculator and attach the I and the J. But do y'all see that you can also go back to the unit circle and look up those x and y coordinates? As long as your angle that they give you is in the unit circle. If it's not, then you're SOL. And y'all know that means sure out of luck. You're sure out of luck. Okay, do I need to do another one of those, or was that satisfactory? Was that good enough, or you need to see another one? Yes or no? We're good? Okay, we'll move on then. Number 71. And we've got vector V is 4I minus 2J. It says find the direction angle. Find the direction angle. Did I give a formula for that? Really? Oh, there it is. Bam. Direction angle. All right, so let's see here. That's going to be the inverse tangent of B over A. And that reduces to negative 1/2. And I'm going to go ahead and tell you that I want that angle to be in degrees. Huh? Because the answer in my book are in degrees. Now, the instructions do not specify. But the answers in my book are in degrees, so I'm going to want a degree. And as soon as somebody gets a calculation for that, I'd like to know it. All, let's say, to the nearest tenth. Okay, now look at this. I really would prefer a positive angle. I'm not happy with negative angles. I want a positive. So what would be the positive equivalent? 333.4 degrees. Aha, look at this now. How did I get that? She told me. Oh, I can tell you though. Do y'all see that this angle, since it's negative, means to go clockwise? And 26 degrees is not very far. That's going to be a little bit into quadrant 4, right? So if I'm at this angle and I want to return to this location, how far do I have to go? A full circle to get right back to here, right? So I'm thinking what you did is you just added 360 to this. Everybody see that? If I'm pointing down this direction and I want to return to this location, I've got to go a full circle to get back here. And a full circle is 360. Now, let's prove it. So to graph this vector, do y'all remember I said that the I component is the X component of the vector? So if I start at the origin, if I say the origin is the initial point, then the terminal point is going to have to be over 4 and down 2. Okay, so the negative 26.6 is that angle right here. Got it? So if I go from here all the way back to here, that's a full circle. And does that angle look like it's about 333.4 degrees? It does. It's in the fourth quadrant. It's really close to the x-axis. It's almost a 360, yeah. So we feel good about that. So do y'all see that you can actually sketch the graph of the vector to check and see if your angle looks right? How was that? Was that good, or you want to try another one? You want another one? Okay. I got the perfect one. I got the perfect problem. 69. Number 69. It says V equals negative 3 square root of 3I plus 3J and the instructions say find the direction angle. So what is the value of A and B? And to find the direction angle, that's going to be the inverse tangent of B over A. That's okay. We'll miss you. What's going to happen to my 3's? Bam, cancel. And that's going to be the inverse tangent of negative 1 over square root of 3. But do I need to rationalize the denominator? Yeah, let's go ahead and do that just for fun. And so that'll be the inverse tangent of negative square root of 3 over 3. And I can't wait to see what you get for an angle. Inverse tangent of negative square root of 3 over 3. And I'd like that in degrees. Anybody? Did anybody else get negative 30 degrees? Let's put a pin in it, okay? Let's hold that thought, Cassie. Hey, let's call timeout, okay? Timeout. I'm thinking this. You know why I'm thinking this? Because I'm thinking what I just taught you how to check it. Let's graph this and see where it goes. What is the x component of the vector? Is it negative or positive? And that means that I'm going to go over to here. And what is the y component of the vector? Negative or positive? And that's going to go up to something like this. So that vector is actually going to point into the second quadrant. But what quadrant is negative 30 in? Do you notice anything about those two vectors? How many degrees out of phase are they? They're 180 out of phase, right? And so in order to make this angle correct, I don't need to add 360, I need to add 180 to get it to be in the right location. All right, so what is the actual correct direction angle? I'm sorry? What'd you say? 150 degrees. And that is a second quadrant angle. And now that matches up with the way that the vector graphs. It graphs in the second quadrant. Now I've got a second quadrant angle. Do y'all see how important it is to sketch a little graph of the vector to make sure you've got the angle in the right quadrant? In fact, this kind of matches up with something else I taught earlier. I think at some point I said something like if x is negative, you have to add 180 to theta. Do y'all even remember what section that was in? That was in the section when we were doing the polar coordinates. You remember we were converting rectangular to polar? And I said if x is negative, you have to... Hey, look at this, same thing. But now it's a instead of x. So what happens if a is negative? Got to add 180 to theta. Still applies. If the x component is negative, you have to add 180 to theta. How often do you do that? Every time x is negative, or in this case a. And does anybody have any questions so far? All right, I've got about 15 minutes of class time left, and I've got a whole nother section to cover. So let's get to it. Section 9.5. Oh, what did I just do? Delete. Bam. Clicked on the wrong thing. 9.5. This section is on the dot product. Finding something called the dot product. And I have a formula for you. So when you're finding the dot product, it's always going to be the dot product of two vectors. Here I've given you vector v and w. And do you see I've designated between the a's and the b's, I've got a1 and a2 and b1 and b2. So to find the dot product of these two vectors, here's the formula. So far, so good. Do y'all see how freaking easy that looks? Oh, let me break it down for you, okay, to show you just how easy this is. If you know how to multiply two numbers together, and if you know how to add two numbers together, you can do this. If you can simply multiply and add, you've got this, okay? Super easy. And I just realized that this section has something else besides just the dot product. So let's add an and sign, dot product and the angle between two vectors. They're also going to want you to find the angle between the two vectors, and I've got a formula for that. It is the inverse cosine of the dot product divided by the magnitudes multiplied. And that is the angle between two vectors. And I like the way it rhymes. Did y'all hear how it rhymes? The inverse cosine of the dot product divided by the magnitudes multiplied. That'd make a great tattoo right there. That looks it. Huh? No, I wouldn't get it. Maybe after I get a little bit older. What? Desmos. I'm going to get a Desmos tattoo. That's what I'm going to get. All right. Would you like to start with a baby problem, or you want to start kind of intermediate? Huh? Okay. Well, that would probably be number 9 then. We'll start where you can understand. And we got vector v is I minus j, and vector w is I plus j. Yeah, we'll start easy. So what are the values of a and b this time? They're all 1s. Do you see that? Oh, except for the first j, it's a -1, but they're all 1s. And the first thing they want me to find is the dot product. So if I'm doing the dot product, what does it say to do with the a values? The a's need to be multiplied. So what is 1 times 1? Good. And then what does it say to do with the b values? Multiply. So that's going to be -1 times 1. That's going to be 1 minus 1, which is 0. And this is important. Anytime you get a dot product of 0, that means that your vectors are orthogonal. Did y'all get that? Anytime you have a dot product of 0, it indicates that your vectors are orthogonal. And do y'all know what that means? I'm not going to tell you. Google it. No, I'm teasing. What we're going to do, this was part A, was find the dot product. Part B, it says find the angle between the two vectors. And now we're going to use this formula, finding the angle between the two vectors. So that's going to be the inverse cosine of the dot product. Do y'all see that? The numerator is the dot product. But didn't I just calculate that? So what is the numerator? And if the numerator is 0, does it really matter what the denominator is? 0 divided by any number is 0. So I don't really care what that is. Yeah, so I'm just going to leave it in its formula form because it doesn't really matter what it works out to be, because that's going to end up being the inverse cosine of 0. And what does that calculate to be? Anybody get that? And now you know what orthogonal means. It's a fancy word that means perpendicular. Orthogonal. Right? If two lines are perpendicular, they meet at what angle? 90, right? That's a pun. 90, right? So if your dot product is 0, that means the vectors are, which means the angle has to be, did you get that? All those go together. All three of those go together. And I think I have just enough time to do one more problem. So we'll do number 13. And believe it or not, that will be satisfactory coverage of this section. Yep. Number 13. We've got vector v is square root of 3I minus j. And vector w is I plus j. And so the first thing they want me to find is the dot product. And I don't know if you noticed, but it makes it a lot easier if you stack the two vectors on top of each other, because it lines up the A's and it lines up the B's. So what is square root of 3 times 1? And then negative 1 times 1. And that is the dot product exact. If they say give the exact answer, that's the exact answer for the dot product. Part A. Now for part B. We're going to find the angle between those two vectors. And that is going to be the inverse cosine of the dot product divided by the magnitudes multiplied. OMG, I'm going to have to find the magnitude of each one of those vectors. Road trip. Do y'all see I'm coming over here to the side? I'm taking a road trip over here to the side to get the magnitudes. So for vector v, that's going to be the square root of 3 squared plus negative 1 squared. And that's going to be the square root of 3 plus 1, which is square root of 4. which is 2. So far, so good? That is my magnitude of V. And then I need the magnitude of W. Square root of 1 squared plus 1 squared. Square root of 2. And that's not going to simplify. Anybody have any questions? Hello, questions? Okay, now back to the formula. Magnitude of V, that was 2, times the magnitude of W, that was square root of 2. And at this point, you're going to need to put all of this junk in your calculator and do the inverse cosine of this fraction. All right, so I heard 58.8 approximately. Let's see if we can get verification. Anybody else doing the calculation and can verify that? 75? Do you mind if I look at what you input? Okay, I see here. That closes the numerator. Oh, and it's only seeing the 2 in the denominator. Because you need another set of parentheses around the denominator. So, do you mind if I put them real quick? So we're going to go there and we're going to insert. Oh, snap. Look at that. Just parentheses. So it's not 58.8. What is it? 75. Even? Yep. And you know what I have to do? I can't just take you at your word. I need to prove it. And so to prove it, what we're going to do is we're going to graph both of these vectors and see if it looks like the angle between them is about 75. So vector V is going to be about here. That's vector V. And if you're wondering how did I get that, do y'all see that the x component is square root of 3? And that's about 1.7. So I went to about 1.7 and then I went down 1. And that's vector V. And then vector W looks like that. He's over 1 and up 1. And then what we calculated was theta here. So does that angle look a little bit less than 90? It doesn't quite look 90, does it? And so that makes me feel good about this. Yeah, that looks like it's about 75 degrees. Do y'all see you can graph and check? Yeah, that's good stuff. And that wraps it up for today.